It's Ms. Hall,
And Ms. Nelson.
and we are starting our probability unit.
Okay, so probability is a number from 0 to 1 that tells you how likely something is to happen. Okay, typically you are going to have probabilities in fractions or percents. It is possible to have them in a decimal, but we don't see those near as often as we see our fractions and our percents. So make sure, we're going to get very comfortable with our fractions in this unit because we're going to be using them a lot. So if we look at our pie chart, okay, if I wanted to know the probability of landing on each one of these pieces in the spinner, okay, first I'm going to count the total number of pieces. So if I count 1, 2, 3, 4, 5, 6, 7, 8, I have 8 possible outcomes. Okay, and possible outcomes are something that you're going to hear us talk about a lot, and that is called sample space, and we're actually going to get into that a lot in a little bit later. But we're going to go ahead and start using those words now, so you get used to hearing them. So if I break this down, I'm going to break it down into each letter. That way we know what my probability is of getting each letter. So for an A, okay, my possibility of getting an A, the probability of getting an A is 1, 2, 3, 4. So there are 4 out of 8, which we know simplifies to 1/2. Okay, same thing with my B's. I'm going to switch colors for you. Our B's, I have 2. It is the 2 out of 8, which is simplified to a 1/4. My C, I have 1 out of 8. That cannot simplify, and obviously my D is 1 out of 8 as well. So again, you see that we have fractions. It would be possible to turn them into percents, but most of the time you are going to see fractions.
Okay, theoretical probability is what is expected to happen. In theory, what you expect to happen. So let's go back to our spinner example. What we expect to happen every time we spin is that we would get an A half the time, we would spin a B a fourth of the time, and a C and a D an eighth of the time each. So the way we do that is probability of expected. Oh, I just said it verbally, and it's right here, probability of A. Miss Nelson already did that for us. Thank you, Miss Nelson.
We're tired. It's been a long day.
For sure. So that's what is expected to happen. So the number of favorable outcomes over the total number of possible outcomes is our, and that's how we calculate that. An example is you toss a coin and getting a head or a tail is 1/2. So 1 out of every 2 times, in theory, that you flip a coin, you'll get heads or tails.
Also, one extra piece about theoretical probability. Something I like to tell my kids is theoretical probability is the perfect world. Example. So no outside factors, nothing going on in the perfect world. This is what should happen, which is why we call it theoretical. So going on to experimental. Experimental probability is found by repeating an experiment and observing the outcomes. So you are physically doing something here. An experiment has to take place. Now, that doesn't mean that you yourself actually have to do it. It could mean that you were given the information of an experiment, but an experiment actually took place. So if we look to find the probability, how you find it is the number of times an event occurs out of the total number of trials, okay? So this is very important because this is how we are going to set it up. Just like in theoretical, what I just boxed is how you're going to set it up. So an example, you tossed a coin 10 times and recorded a head 3 times and a tail 7 times. So My probability of a head is 3 out of 10. It physically landed on a head 3 times out of the 10, and then you would always see if you can simplify it. And the tails is 7 times out of the 10, and neither one of those can be simplified.
Okay, so now we're talking about if it's likely to happen or not. So let's go back to our heads and tails example. In theory, your chances are even, or 50-50, or 1/2 of the time you will toss a heads or toss a tails. If the theoretical probability is less likely for that to happen, then it would be here unlikely. If it's impossible, an example of impossible is the sun rising in the west, then it would be 0. Now, likely, if it's more likely to happen, it's 1/4. If it's certain, like the sun rising in the east, your theoretical probability is a 1. So it's always going to be between 0 and 1. When we're dealing, Ms. Nelson said that we're going to be dealing with a lot of fractions or percents. Percents are out of 100, fractions are out of 1. So we're from 0 to 1, that's what your probability should look like. So if you get something more than 1, when you're solving something, you need to go back and look, you made a mistake. So let's use our head toss, our coin toss down here instead of A. So the probability of tossing heads, theoretically, and tails are 1/2 and 1/2, right? So we would say that, experimental. Sorry. Experimental on heads. So theoretically it's 1/2, but then our experimental, when we look up here, was 3 out of 10. And then in theory, our of tossing tails, theoretical would be 1/2, and our actual, what they told us, tails, is 7 out of 10. So sometimes your theoretical experimental will be the same, but actually that rarely happens. Usually chance and, like Ms. Nelson was saying, outside forces come into play, and it's not exact. Okay.
So if we go back and look at this question, it wants to know which is more likely to happen, my theoretical probability of landing on heads or the experimental probability. Sometimes it's hard to be able to compare fractions when you don't have unlike denominator, especially if you can't visually see them. So my 1/2 is the same thing as 5/10. Now I know which is more likely to happen, my theoretical probability of 5/10 or my experimental probability of 3/10 of landing on heads. My theoretical probability beats out the experimental probability. So my theoretical probability is more likely to happen than my experimental results from the information that we were currently giving.
In this scenario.
In this scenario, everything is very specific to the specific scenario that you are working in. When we compare a theoretical of tails, again, 1/2 is 5/10, and the experimental probability was 7/10. So in this case, the experimental probability of getting tails was higher. It is more likely to happen because 7/10 is higher than our 5/10. So we're going to continue to work over this over the next several days and when we come back to class. So make sure if you have any questions over the basics of what we just covered, make sure you come and ask us. Bye.
Bye.